welcome Kiryl. Everyone give Kiryl a hand as we learn about Appium automation for games, Unity.
All right. Welcome everyone, and today we're talking about using Appium for Unity games automation. So where it actually works, where it fails, and how exactly we manage to make it useful for our testing workflows. And now let's become a little bit closer. So my name is Kiryl, and I'm a test automation engineer at Triple Dot Studios, working at Warsaw. And I've been in QA for about 8 years with a deep passion for automation infrastructure and building frameworks for mobile automation. And basically, I'm just an average Selenium Appium enjoyer, always looking ways to push automation further. So let's explore how Appium fits or not fits into game testing. First, I'd like to start with a common introduction where we're going to discuss some few common things. So we align our vision of test automation of mobile approaches or mobile automation approaches and compare how testing types of the standard mobile application can be compared to testing types of the game automation. And then we'll talk how our first attempt of using Appium for Unity game automation was failure and how exactly it was failed and how we managed to overcome it. And now, after that is going to be the biggest part of the deck. It's 2 features. So we'll discuss the features of Appium that we actually found useful for testing. And after that, we'll wrap everything up. So let's go. And I want to start the deck with some simple, familiar concepts, some things that are easy to grasp and comfortable to think of. So gradually we will increase the complexity of the topic based on some things that we already know. So just for now, just relax. Imagine any mobile games that you would love to automate, some simple, and just let's ease on that. First thing that I wanted to say that is game development is a really unique area of IT, of the development itself. It's not harder, it's not easier, it's just different. So it's a different, some blend of creativity and some unique technical challenges. But from the QA perspective, things at a first glance may look kind of familiar. So we also have a bunch of functional tests. All of this, go to page A, click button B, all of this stuff. We also have some UA, UX, and accessibility checks. And of course, we have some performance testing that you probably needed to be implemented like yesterday. And what makes functional game testing is different is the very idea of what function is. So when you think about some standard application like Messenger, something like that, so the simple example of function is going to be like send a message, change your status, or just change settings, something like that. So when you think about any game, the biggest part of any game, it's a gameplay. It's a time when our user is actually playing, doing some things, spending some time enjoying all of this process. So for the game testing, example of some function that we can write functional test for is the actual sequences of action where our user is playing. So it's win games, lose games, some scoreboard, some leaderboard, some calculation, all of this stuff. And on the next screen, we can see example with one of our game. It's called Sudoku. And there we have a good example of the functions that the functional test can be written for. It's simple lose game scenario. So we have a board, we have some figures. You need to move figures in some exact order to your board, and you will receive a pop-up. So if you already have any experience with any automation framework, Selenium, Appium, anything, you can just imagine the test structure. So you initialize the objects, you initialize the game boards, you just swipe in it, and you will validate the existence of the pop-up at the end. So it's super, super similar, but you need to keep in mind all of this idea of what function is. And now let's take a step back and discuss the approaches for the mobile automation itself. We have two simple approaches for the mobile application automation. So the first one is so-called white box, when your testing framework has access to the client code base. So this is a place where you can use tools like Espresso, like XCTest. These tests are fast, reliable, they have access to some internal APIs, all of this stuff. And on the other hand, we have the frameworks like Appium, where you act like external user. They also great because they give you a vision of how your application works with some external interactions, like a black box for some external user. And for the game automation, this thing's starting to look kind of different. So we still have the same approach for the white box testing. So we still can integrate some testing tools inside our client code base. So normally for the Unity or maybe Unreal Engine games, it's going to be some C# repository. And as an example of such framework, it might be something like Unity test framework. But when we go to the second approach, to the external user approach, here we have a problem, because games just can't be played from the outside. So we don't need to like deep dive into it. For now, we just need to keep it in mind that we can't play games from the outside. We need to make our builds like instrumented with some testing frameworks in some or any other way. So we'll discuss it a bit later, but for now, this should be like the thought that you need to keep in mind for some time. And now we go into chapter 2 failures. We will discuss why exactly Appium is not a best solution for the mobile games automation. So on the screen, you can see the example of the Confetti app, which was built by John O'Reilly for Kotlin Conf, and there we have a great example of how Appium should work. So this application was built using Kotlin multi-platform mobiles, and under the hood it used the native Android UI framework. So we can see all of these native UI elements. We can see views, inside of views, we can see all of these buttons, we can see the text, and of course, because of that, we can like verify something. We can define these elements into our testing framework. We can interact with them, and of course, we can like do all of our automation thing. And on the next screen, we can see like, yeah. So we can see the great example of how all of the Unity games will be looking on in Appium Inspector. So we can't see any elements at all. We can't see views, we can't see text, figures, or anything. So it's just totally blind to Unity games. So we can see only this one view, which is like game view, what? So why is it happening? What is the reason of all of this thing? So basically, main issue is kind of simple. Game engines, they totally don't use some native UI frameworks. They don't use native Android, native iOS frameworks, or native frameworks of any other platform. The reason of it comes down to Unity core philosophy. It's a multi-platform compatibility. So Unity is a game engine that is created to support games across different platforms. It's not only Android or iOS. It also could be some game consoles. It's also web. It's also some Linux, Windows. All of these operational systems can be supported in Unity games. And that's why Unity needs to be abstracted from some native UI frameworks. And that's why we can't use any native UI hooks. We can't like use Appium to interact with those elements, or either way, we can't define them. We can't see them into Appium Inspector at all. And if Appium doesn't work from out of the box. So do we have any alternative for game testing? On the screen you can see a few examples of those tools. The most popular is Altester, it's Unity testing framework, already mentioned, it's Game Driver, it's Pocore, or you can use some new AI-based image recognition frameworks that can identify your element on the screen based on some text description. So for our testing workflows, we selected Altester Unity, but it's not the point. So in the future slides, we will call it as a gameplay driver in order to not be like confused with all of these names. And on the next screen, we hit into the two features, to the biggest part of the deck. We will actually discuss the features of Appium that we found useful. So this section will be divided into three independent sections. Is app control, is native testing, and is performance testing. So app control is basically all the things around the application. So about installation, about launching, about removal of it. And on this slide, you can ask me kind of a reasonable question, like, why do you need to handle all of these things with Appium? So why your testing frameworks don't do all of this stuff? And it's a good question. And to understand the answer on it, we need to get back to a few slides and remember this thing that I said, that each game build needed to be instrumented. So simply, we need to integrate these testing frameworks inside of the game. So that's why they became like a part of the game. Game can't install themselves. They can't like remove themselves, or they can't control the state of themselves. And that's why we need some external tool to handle all of these things for us. And Appium is a great tool not only for the UI automation, but also to handle all of these things, to make all of these interactions, and to help us to control our applications. So for us, it was really savior that at the end of some Unity builds, we also receive some files with native extensions. So it's APK for Android or APA for iOS. And that's why some default capabilities for Appium works great with that. So we just simply can't set up Appium the same way we do for any other application. So it's automation name, like UI Automator for Android and Android, for platform name, and of course, device UDID. So we can see the code snippet. It's super simple. It's nothing specific is happening in the slides. And now we're going to talk about how we install our application. So here we have the same approach for communicate to connect with application works as with any other standard app. So we just need to select either we want to install our application from binary, or we want to use some pre-installed application using some package name. So on this slide, there's also nothing specific happening. We can use app package and define the location where our binary file is located. And there we can see that we can, using app capability, we can define the package name of the already pre-installed application. So normally for Unity game, we use the same pattern as we have for any other mobile games. It's like com.company name, .game name, something like that. And we also can see one interesting thing over there. So we have app activity, like for Android applications, you need to define the activity from which you want to start your application. And normally, like for Android apps, it could be something like main activity. And for Unity games, we also have some standard activity, which is on the screen is com.unity3d.player.something.com. So this activity is needed for Unity to start all of these Unity life cycles, to handle all Unity UI inputs in order to your game to be workable at all. So if you want, you can extend this activity, and your developers can do it if they need to use some native UI things before the application will be started. They need to like extend this class, extend this activity, and of course you need also to replace it into your Appium capabilities. And we also have the concept in Unity Gaming which is similar to activity, which is called scene. You can like switch these scenes within your tests. If you want to, you can start your test within some pre-selected scene if you want to make your tests like faster in some way, but normally you just set this capability and it just works. And we have the final capability to handle. It's some controlling the alert, controlling native UI elements, it's controlling timeouts and controlling auto launch. So normally, in some basic cases, you also will handle those first capabilities like auto-accept alerts and auto-grant permission. You also will set them to true, because normally, you don't want these native UI elements, even in some native applications, you don't want them to be interrupting your tests. You just want to Appium handle all of these things, right? So it's also the same way, works the same way with Unity, but for Unity games, we need to remember that we integrate our testing framework inside of the game. So our testing framework is incapable of doing anything with the native UI elements at all. So it can't just close them. It can't just handle them in any other way. So if we will have this native pop-up within our gameplay test, our test will be just broken, it will fail because gameplay driver can't handle it. And that's why this capability is kind of crucial for handling it using Appium. And the second one is the new command timeout. So since Appium is already installed application, launched it, verified its state, this application is already launched, Appium just goes to some idle state. So we don't use Appium within our gameplay test at all. So it's just sleeping. And if we don't want Appium to be terminated due to some inactivity, you need to think how big you want this timeout to be. So normally, of course, you want to make your test as quick as possible, make your Appium session as quick as possible. So, and you need to think about this timeout, you need to discuss it with your team, you need to like make an agreement on how big you want this session to be at all. So the idea to set the biggest possible timeout is not good at all, because if you will have some bug in your framework, then you might have Appium sessions like waiting to be terminated for 20 or 30 minutes. It's not good at all. And we also have the capability to auto-launch our applications, because normally we want them be launched automatically, but sometimes we also need to make this capability flexible, to change it to false. And we will discuss such scenario in our future. And last but not least, we need to start our driver. So after that, the Appium will install application or launch pre-installed, launch it, and go to the idle state. So now we're into the game, and let's kind of deep dive into this concept of using two drivers at the same time, to use two drivers simultaneously. So after the Appium already make all of this job related to app control, to the installation of app, all of the things, now we have our gameplay driver on the scene. So from now, all of these interactions within game, all of these gameplay tests at all will be handled by gameplay driver. And these drivers, they're not kind of competitors, they complement each other, they can coexist together. So of course, we need to carefully control them, because you can't just start this gameplay driver before Appium driver, because your game isn't installed yet. So it's kind of straightforward and simple things, but you need to handle this. You need to think about it within your testing framework. You just need to be really, really carefully. You need to verify after the Appium already did all these things. You need to verify that your game's in the correct state before start some gameplay test, because gameplay drivers simply are incapable to do any of those things. So it's kind of teamwork, yeah. Gameplay and Appium driver. And it always feels really great when our tests are like implemented, they're executing, we have test results, managers are happy, right? No, of course not, because sometimes our tests are failures, because we have some bugs, we have a flackiness, maybe we have some bugs in our tools or some problems with the real devices, yeah? So guys who worked ever with real devices will understand the problem. And of course, we need to handle the outputs in order to have a proper debugging session after these failures. And we can handle all of these things using Appium. Appium is really great in all of this because Unity driver, this gameplay driver, is inside the game. It don't have any access to the logs of the device. It can't just make a screenshot of the whole device screen. We can't just even call it a screenshot if gameplay driver will make it. It's more like a snapshot of the current game state. But sometimes we might have a problem that we have some native UI element on the screen and our gameplay driver just incapable to close it. And by doing screenshots with the gameplay driver, we just can't see the problem at all. So Appium is the only good solution out of the box from this one, so we don't need to use some external tools. We can just use Appium methods for this one. So on the screen we see the really simple example of how we can handle logs or screenshots using Appium. So these code is cross-platform, so you can use it either for Android or your iOS tests. And now we hit into the native testing section. So this section also will be separated into two parts. The first one is about handling native elements within gameplay context, and the second one is handling native elements out of these some native context. And because we have our tests running, our games running full screen, and because they run on some native platforms, sometimes we need to handle native elements like permission requests, like some legal pop-ups or some redirects to web views or actual web page for some legal information. And we still can use Appium for all of this stuff because Appium is in the idle state, but it's still workable. So we can't just call it from anywhere in our code, and we can ask him, so Appium, please close this pop-up or verify anything on this pop-up. So it works the same as you will implement it in any of your native testing frameworks. And in the first case, like I mentioned, we'll discuss handling these elements within gameplay context. So scenario is pretty simple. We have our game, we play our game, and then bam, we have some native elements. We need to handle it. We need to verify something on it and just move on. And we are getting back to these capabilities again. Yeah, auto accept alerts and auto grant permission. So these capabilities for now, we need to set them to false if you want to handle them using Appium, if you want to handle them manually. So the great scenarios, a really good example of scenarios, why do we need it at all? Because sometimes these we want them to be, we want them to, in order to verify their existence, verify the content in it, and verify that our user will be returned to the proper game state. It was before he received this pop-up. So you need to manage to handle these capabilities in order to use Appium for handling them manually. So now we're going to good old friend Fudoku again, and there we have a super different picture. Yeah, we can see that now we have all of these native elements on the screen. We can see that now. We can handle them. We can identify them. We can see the paths, and we can see all of these accessibility hooks that we can use to find these elements within testing frameworks. And this is one of my favorite screenshots. So there we have some super simple page object model. So while we using this weird concept of having two drivers at the same time, we still want to stick to some standard mobile, standard automation patterns. And of course, yeah, super famous. I don't know any person that didn't heard about page object model. And the best part of it that we can simply having these elements from Appium and from gameplay driver in the same place. So we don't need to separate them. We can define elements in the page object for Appium and for gameplay driver, and we can use it in some test layer or any other some abstract layer like steps layer. We can use it without knowing actually that it is one for Appium driver and another one like for gameplay driver. So super cool. Another great example of some native elements within gameplay context is the native interstitial. Yeah, I also hate these things, but sometimes we need to test them because all of these advertisement providers, they normally create this interstitial using some native UI frameworks. And that's why we also can use Appium to handle all of these things. So scenario is the same as on some previous slides. We need to trigger it, we need to verify its existence, and after that we need to close it and be sure that user will receive some, I don't know, magic coins or something and will be returned to the previous game state. And we can use Appium to close this little tiny button in the top of the screen. And the second case is the handling handling native elements outside the native context. So normally in the testing of some native application or testing some Unity games, U is located into the same context. It's probably some native context or web context if you're testing some mobile web applications. But sometimes you will have some cases that you actually want to switch the context, that you want to, I don't know, go to some web browser from the game, like some social network sharing, social network account connections, or just some legal things that you need to go from some privacy policy links, all of this stuff. And with Oko again, we have this settings menu, we have two buttons, terms and conditions, privacy policy. After clicking any of those, you will be redirected to some standard browser of this device. And you need to handle something in this browser and return back to your game again. And there we have super simple setup for iOS, how to handle all of this. So all you need to do is to set up one capability, and that's all. And with Appium, you can simply switch context to the context that you want to. And you just need to find the correct one, which is will contain the name web unit, and just simply switch to it. And after that, you will have access to all of these methods and variables of the web context. And there we have the simple example of the test that can be implemented for this case. If you want to assert that U is located on correct page after this navigation operation. So nothing specific over there, but super handy example of such test. And now, also my favorite section is performance testing. In the context of the current talk, it's more like performance tracking, but we will call it testing to not be confusing. And performance testing is everything for mobile games, because users they don't want to wait 5 minutes before your application will be loaded. They don't want your application to store too much cache into the storage of your device, or they don't like your games if your game drains battery too fast. So we all know this, we all work with this, and from the test automation perspective, it's kind of a good case to leverage Appium capabilities again. So I know, and we all know, that Appium isn't like intended to be a performance testing tool. Yeah, we all understand it. But we can use Appium as a great starting point to already have some benefits in performance testing, to have some insight, to actually achieve something. And it's also a good thing to like experiment with it, to see how you can start performance testing, and after that, if you will see that you need to some other tools in order to make a great performance testing solution, you also can integrate them into a framework. You also can implement them. But Appium is, as I mentioned, is a great starting point for this one. And this section also will be separated into two cases. First one is about Appium Images plugin. So for those who don't know, this plugin actually have two main functions. First one is to find image by some template, by some baseline image. And the second one is to compare images. So we are leveraging the one of this function in order to implement test to gather the uploading time. So for us, uploading time in the context of the games, it's the time from start application, from actually like clicking the icon of the game to the first playable screen. So first playable screen for most of the games is like something like tutorial or any other some classic game. And we also have all of these things. We need to identify that current screen is the first playable one. So you need to have this screenshot, the first playable screenshot of each game into every project that you want to implement performance tests. But the test itself will remain the same, because the idea of it's one. You don't need to have kind of different implementation of those tests for each of your projects if you want to implement something similar. And the scenario of the test is also pretty simple. So you need to actually start the application, you need to start some counter, and you need to constantly check whether your current image is already a selected one, a image of the first playable screen. And after that, you just simply stop the counter, gather those metrics, and now this harder part to understand what you want to do with all of this data. And there we have a draft example of one of those tests that also might be implemented. Here we have some simple, some common Selenium waiter. We have to start the stopwatch, we have to stop it, and of course some waiter, like some condition that we wanted to expect. And this condition for us, it's custom, because we wanted to like extract the duration of the operation of image recognition, because we don't want to have this time into the final one. Yeah, it's having no sense at all, because if you collect the time of the loading game, you want to have like actual time of loading the game. And now we go into the second case. It's hardware performance metrics. And the best part of all of this is that Appium provides you an interface to use some native tools to have a performance metric, to gather this performance metric. So these implementations are kind of different for Android and iOS. It's because of some platform differences, but from the final user, from the test perspective, we also have these data. We tried our best to make our test look the same for both platforms. But from the scenarios perspective, of course, there are going to be some differences. So for Android, scenario is pretty simple. We have our gameplay, and we have to collect metrics. We have to call the methods that will collect some metrics for you. So for gameplay, we need to use something demanding, something that will use a lot of pop-ups, a lot of animations, a lot of calculations, all of this stuff, because you actually want to test how your device will act with your game, how your device will interact with your game. And there we have an example how to retrieve those data. So for Android, it's pretty simple. It's like get performance data, and that's all. And you can use this map just to gather some data that you want it to be. It's CPU info, it's memory info, it's network and battery info. But for iOS, of course, we have a different situation because iOS works with the instruments application from Xcode. So you have to actually start recording and end recording. And in between, you will also have the same gameplay scenario. It also could be the same for iOS platform. And there we also can see the difference in the setup. So we need to have some specified arguments for this one. We need to specify that, okay, we want to use some activity monitor, or you can create your own custom monitor. It also will work well if you don't want to collect some performance data, if you want to collect oh, okay, I need only this one or that one. So it also could work. And it also some PID, you can use current if you already sure that you in the correct game, in the correct state. And timeout. Timeout is the time that your performance will be actually recorded. So the recording will be stopped after this timeout, but you will receive any output only when you call this command at the end, stop performance recording. It's kind of weird, but it is. And let's bring everything up. So we started from the idea that Appium is not the very best option for the performance testing. So for performance, for UI automation for mobile games. So what does it mean for us? We still wanted to adapt Appium for our cases. We still wanted to use it because we need it for application control. And after that, we'll bring up with some ideas on how we can use it in some other way, how we can leverage all its capabilities. Because Appium, it's great not only as a UI automation tool, it's also great as a automation tool. So you can use it to handle all of your devices things. You can use it to manage some native elements. You can use it to manage some performance testing, some outputs, all of this stuff. So in my opinion, you need to experiment. You need to try more, handle all of these things using already well-known, tools with having the great community, having the great documentation, all of this stuff. And that's all from my side. Thank you, guys.